Um, okay, hi everyone. Thank you so much for being here. For those of you who didn't get the chance to see my amazing R2D2 heels, now is the time. And I'm gonna walk over there so everyone will be able to enjoy this beauty. Look at that. Come on. Give it up. Come on, you sitting quiet. R2D2 heels. Thank you. Thank you. I deserve it. They're painful. Okay, now we can start. Okay, so hi again. I am so happy to see you all here. I am so excited and honored to be standing on this stage and to get the opportunity to share a little bit of my journey with Helm Charts. And yeah, so let's do this talk. How a unicorn migrated from an in-house solution to Helm. Before I do that, let me tell you a little bit about where I work. I work at Forder, which is Forder ensures that good customers can complete their transactions while fraudsters are blocked. That's a good thing to do. But now you're probably wondering, why a unicorn? Well, first of all, it's a cool name for a presentation. And also, Forder is a unicorn company. So that's why I thought it's a very good name for this talk. And so now, before we dive into the details, I want to give you a little bit of background about Forder so you'll get the idea of what we need to handle. So we need to do 50 million decisions every day in real time. And this is the production environment that I have to support as a platform engineer. And let's talk a little bit about Forder's compute environment. So we have AWS with EC2 instances. There are some things that we might not migrate to Kubernetes, but this is a Kubernetes talk. So of course, we also use EKS. Why don't we migrate everything to Kubernetes? Well, that's a talk that I'm not going to do now, but you can join that other talk of mine. Okay, so now let's talk about the CI/CD pipeline that we have at Forder. Obviously, that's a little simplified overview of what we have. You can see over here that right now, if a developer, they write their code, they write a little bit, they change their Helm chart, then it goes through a webhook to Jenkins, and then we use both AWS ECR and JFrog Artifactory. And as far as the CD, we also have Jenkins for different deployments, but for Kubernetes deployments, we use Argo. And that's it. That's a simplified overview of our CI/CD pipeline. And now I'm going to go back a little bit and talk about what happened about a little over a year ago. So a little over a year ago, we decided to migrate to Kubernetes. It was the second iteration of us trying to do migrations to Kubernetes. And the first time that we tried to do those migrations, it wasn't so successful. And I'm being honest here, and that's okay that it's recorded and live. It's something that I'm allowed to talk about. And the reason for that, we weren't so successful, it's because I think that when you start to do such a huge journey, when you start to go on such a big journey, you need to take into account that the migration phase is not going to be a very short phase. You need to prepare for that because it's going to take some time. And so you need to be able to support both the existing environments and then also the new environments and then have them play together nicely. But the other thing that you need to remember is that your users, they have free will. Unfortunately. No, just kidding. That's a horrible thing to say. But seriously, though, when you decide to do a big change of infrastructure, you need to get buy-in not only from management, but also from the users, from the developers who are actually going to use that new infrastructure that you offer. So you better think about that before you come up with some offering that looks really good, that is very performant. But what about the usability of that? So that's what I'm going to focus on. I'm going to focus on Helm. I will present the technical solution, but what I'm definitely what I definitely hope that you will take from this talk is not just the technical parts. I would like you to open your mind and think about how, when you define the requirements for your new architecture or for your new system, think about who's going to use that and what's important for them, because that's what's going to make your system or your new infrastructure so successful. Because if you have an amazing system, but nobody uses that, is it actually amazing? So that's what we'll have today. We'll talk about these three things. I'm going to start by talking about the Helm Chart's structure requirements, and then I will talk about our Helm Chart's structure, what we ended up doing, and then I will talk about how we integrated Helm with our existing infrastructure as code. But before I do all of that, why don't I tell you a little bit about myself? So my name is Mey Beisaron. I've been a backend engineer for over 5 years, and then I decided to join the dark side and become a senior platform engineer, which is what I am today for the past 3 years. I'm an international public speaker, which means I love to talk a lot in different places, but I'm also a mentor, which means I love helping other people become the tech speakers that they want to be. So if you want help, talk to me. I'm a party girl, not the kind of parties that you might think. I love to join Diablo 4 parties. Woo. Okay. And I'm a sworn Star Wars fan. We covered the R2-D2 heels right at the beginning. So for those of you who just joined the talk, I have R2-D2 heels. They're shiny, they're beautiful, and painful. Give it up for that, just one more time. What do you care? Thank you. I love this audience. It's so nice. Okay, so let's start with the Helm Chart structure requirements. Let's see that. So I started to talk a little bit about that. The fact that developer experience is important. It's something that it's not always easy to measure. It's not so easy to make it a measurable something to go by and to prove to management that what you're doing is very good because the developer experience has improved. There are ways, obviously, to measure it. So one thing that we did when we embarked on this journey is we handed out a survey to our developers. We made sure that the survey wasn't too long, no more than 6 or 7 questions, and everything was just a selection questions, not open questions, so it won't take too long for them to fill, because who likes surveys? I don't think a lot of people. But this was our way to be sure of what they want. What are they looking for? What's missing in our current offering in terms of deployment or the way that they can define their resources? So we started with a survey, and we kept that survey aside, and then later, after we went through the whole change and Kubernetes migrations, we handed out the same survey. And that was a measurable way for us to show management that what we achieved. Are they happier now? Or do the developers believe that it's easier for them to do deployments now? So it's not just about Kubernetes, saving cost or having faster deployments. It is the most important thing. We are a business after all, right? But if a developer say that now they believe that they can create a service much faster, that their deployments are faster, that they can debug their problems in a more efficient way, that's a big achievement. And that's what we were able to achieve with that survey that we handed out. So that was about the survey. I told you about the beginning and the end of it and how we used it. But now let's talk about how we defined the requirements for the new Helm Chart structure. Now here's the thing. Before we migrated to Kubernetes, what we had was a Python solution, an internal Python solution for defining all of the cloud resources. It means that you can write code in Python, and this Python code will generate CloudFormation templates, and with that, you will get the resources defined in AWS after deployment. Does it make sense? Okay, cool. So now it means that the developers are used to defining their own resources. they're used to managing their own resources, selecting the type of instance, selecting their type of queues, even defining the security groups. So they are aware of how to do that. They know, they're used to that. But still, I wanted to ask them if they like it. So some developers, yes, they loved it because they felt that they have so much power. So they wanted this autonomy to keep on going even when we moved to Kubernetes. But some developers just found it too complex. They felt that all they want to do is focus on their code, and they want me or somebody else from the platform team to get it up and running. Just do something, make it run. I don't want to define security groups. It's not that important for me. I can understand that. And as the company grew more and more, we had more and more developers thinking like the second option, more and more developers looking for the golden path, saying, I don't know, I'm not so excited about defining the cloud resources myself. Okay, so this is why we understood that now we have to find a way to support both approaches. We need to find a way to allow developers to have enough flexibility to change things on their own, but also, on the other hand, I want to have enough abstraction of the infrastructure, of some infrastructure parts, to prevent cognitive overload. So here are the three requirements that we had we decided to go by when we started to think about what's the Helm structure is going to look like. The first one was to say, okay, we want this to be self-serve. We are a team of 5 platform engineers on the deployment pipeline, and then we have 4 more engineers on the CI pipeline, and we need to serve about 120 developers. So we want our solution to be self-serve. We don't want to be a bottleneck. So we want them to be able to change things on their own. Next, we have the Composable. We want to allow deployments to be assembled from smaller independent components because it means that we can abstract away some of the underlying infrastructure, and then we can start building on top of that. And then we can decide if we want to change one part or not. So composable, that is very, very important. Even more so, that was important for us because we came from that Python solution, which was a big repository with everything defined inside it, which has its own strengths. We can talk about that later if you want, but believe me, it's not like just 100% bad to have everything in one repository. That's not definitive, but it's something that we decided that we kind of want to find a way around and to have the next solution be composable of many different parts. Extensible. We wanted to make it easy for everyone, not just us, the infrastructure team, to add new abilities to that Helm solution. And why is that? It's because today, as I mentioned, developers are used to be able to add new features to that Python code. If there is something new that AWS now came up with. So a developer can now just use the AWS CDK API and go ahead and add this to the Python code. And now this new resource will be generated during deployment, and it's part of our ecosystem. So we wanted to take that ability onto the new Helm Chart architecture. So when developers define resources for Kubernetes, if there is something new that came up, they don't need to wait for us to add it to the new offering. So these are the 3 requirements. And we wanted to have Helm charts that make it simple to add new abilities, to make it composable, so we have different parts, and we wanted it to be self-serve, so people can use that on their own without waiting for us for anything, basically. So I created this very simplified graph because graphs are nice. But also, I wanted for me to have a way to communicate with you about how I felt about each solution. And when I say felt, I mean it because I am an emotional developer. So let's go over to the second part. Now we will talk about the evolution of Helm Chart structure from conception to our solution. Just so I'll know, how many of you here are familiar with Helm? Just by show of hands. Okay, cool. So I'll skip a bunch of stuff. So when we started to think about Helm, we went through we went through the Helm features. I'll go through that pretty quick because I see that most of you are familiar with Helm. So for those of you who don't know anything about Helm, let's say that you have some front-end service that you want that to be deployed to Kubernetes, then you need to have your chart, and this is your way to define some resources for this application in Kubernetes. So in that Helm chart, you will have a chart YAML. You're going to have templates, which is like a fundamental concept that allows you to define the structure and configuration of a Kubernetes resources in a flexible and reusable way. I think about it as just functions, but it's templates, really. So then you also have the values YAML. This is where you manage all of the actual values of what's going to be deployed. We use the values YAML in order to simplify our Kubernetes offering. So that's general. For those of you who already know Helm, you're probably familiar with it. And now I'll go over one more thing that is, I think, important just to be sure that everyone's aware of it. So in Helm, you have the chart YAML, which is a metadata file. And that provides essential information about Helm chart, like the chart name, the version, the dependencies. If you take a look at line 7 to 9, you can see the dependencies over there. What it means is that now we can use that chart that is defined elsewhere, for example, where it says repository and then charts, bitnami, we can use that chart and in our chart. This is actually called a subchart. The dependency is called a subchart, and while there are many things to talk about when it comes to Helm subchart, I think it's a wonderful concept. I want to focus on the two characteristics that we leveraged in order to get the solution that we have today. But another thing that I want to say is that the main chart, the one that I work with on my service, this is called the parent chart. So remember that when I tell you the next thing. So a parent chart can have multiple dependencies. I can decide how many dependencies I want. It doesn't have to be databases charts. Obviously, it was just for the examples. And then another thing is that you can enable those dependencies by condition, by a simple flag. And another important thing is that a parent chart can override values of their dependency chart. Now, why that is important, it's because now we can use ready-made charts from third parties or open source charts, and we don't have to write these from scratch. Okay, so now let's go over some common Helm chart solutions. But before I do that, let me tell you how I got to that. So when I got this challenge, as I told you, one of the things that I'm most passionate about is developer experience. But I'm also passionate about finding out the things that I don't know, right? Like, what are the unknowns? That's a big passion of mine because nobody likes to be surprised when it comes to production. Some other places in life, surprises are great, not in production. So what I did was I decided to go and ask around people, friends from other companies that migrated to Kubernetes. Because what I believe that is special about being a platform engineer is that different companies, they have problems kind of in the same area, right? Like, companies need to deploy their apps, and they have a CI pipeline, I think, and they need to build, they need to do testing. And if they use Kubernetes, there's a set of tools out there that you can decide which one is best and which one to use. And so what I did was I went to those other companies, not just to ask, is Helm good? Because what does it even mean? Good. Good to who? Good to what use case? What I wanted to learn about was the migration phase. I wanted to learn about the user experience. What did their users think about Helm? Did they like it? Did they feel that it was too complicated? Because I knew that the problem I was trying to solve was to help the developers who feel that the Python solution is too complex, make them feel that we're working for them, and they're now going to get something that is easier and simpler. We have to remember that not all developers are familiar with Kubernetes. For some of them, it was the first time that they did anything on Kubernetes. So I needed to take that into consideration. Obviously, I would like to think that the developers will, explore and read about Kubernetes on their own, but I can't think that this would be the thing for all of the 120 developers. I can't believe that it's going to be right for every single one of them. And so this is why I took the time time from the time that I dedicated for research to ask other companies how was their developers' experience when it came to Helm and other solutions that we checked. So this is what they told me. These are the solutions that I found out that other companies use, and then I'll show you what we decided to do. So some companies decided to manage each service as a single chart, which means that we have a chart per service. And that was actually useful I saw that happening for the smaller companies. For startups where the DevOps or infrastructure team, they manage it all. So they were the ones who actually defined the Helm charts for each team. And I found, in my opinion, it wasn't so scalable but I can say that for smaller startups where their developers really need to be dedicated to developing the services, and they don't have time to mess around with complex infrastructure, this worked for them. So it was an interesting solution. The thing about that is that now those Helm charts are in the repository. The entire Helm chart is in the repository of the service, which means that the developers can now change and edit the chart as much as they want. Sometimes it's a good thing. Sometimes it's not such a good thing, because what if there's a developer who doesn't want to wait for the DevOps team to create a Helm chart? Now you have a copy-paste situation. Does it sound very good? Does it sound very secure and safe for production? No. So that's why I believe that it's far too, it's too much on the developer autonomy. It enables the developer to do those changes and create their own charts. But then if I want to make a big change for all of the charts, or if I want to add some security measures, that's going to be pretty tough if every chart is separated in different repositories. So if I want to sum it up, with individual charts, we don't have standardization. It creates cognitive overhead, because as I said, I can't ask 120 developers to go and read about Kubernetes and get into all of the details so they are able to write Helm charts from scratch. And yeah, compliance, security, that's not a good idea, at least not for further where we're at today. This thing has worked for smaller startups. Next, we have the umbrella charts, which mean that we manage all services subcharts in one big single parent chart. So let's see, what does it look like? So let's say that this is my directory, right? So if I want to deploy anything, it means that now I will have service chart 1. When I say service chart 1 and service chart 2, this means that these are charts for each service. And then this whole thing is one big chart on its own. So we have the templates, the values YAML, and the chart YAML. if I want to make it more visual, this is what it would look like. So it means that the big chart is dependent on those. So if you remember, we have dependencies for charts, which means that each of those charts will be written as a dependency in the big chart. And the fact that the big chart has all of the other chart as dependencies, if you remember, it means that now the parent chart can override values. So this can actually be good if I want to have very strong, strict standardization, if I don't want to allow something that's actually a good thing to do. And another thing that I saw was that the companies who used the umbrella chart were companies who needed a single deployment. There are a lot of companies who needed to be able to deploy their entire environment, their entire services together on one go. And this is a great solution for that. Yeah, so one command, deploy everything. So this is what the umbrella chart was very strong for. And it's actually wasn't just in smaller companies. I've seen a few big companies, I won't name names, but believe me, very well-known companies who use the umbrella chart, and it works great for them. Because as the company grows, like I said, you do want to have a way to enforce some standardization. You want to be able to make sure that some values will not be deployed to production. And sometimes if the company is that big, you don't even want to show it as an error. You just want to prevent it, and then, okay, it will fail during deployment. Okay. So as you can imagine, the umbrella chart is very up high on the standardization. It's a very, it's a very strict manner to use that. And the problem with that, in my opinion, again, I think it's a problem for them. It's not, because it works for those companies. So in my opinion, the problem with that, at least for Forder, is that this repository was managed mainly or solely by the DevOps team. And if you remember, this was one of my requirements. I don't want us five platform engineers to write Helm charts for 400 services or for 120 developers. That's a bit too much. And honestly, because we have that culture at Forder where developers are already used to being responsible for their own resources, I knew that we don't need this much of strict standardization in our new tool. So we decided not to go with that. I wrote here that it's difficult to maintain for big systems. Even though I wrote that, I can't say that it's 100% true. But that's what I felt when I meant big systems. Maybe it was more correct to say that it's more difficult to maintain for the amount of developers versus the amount of platforms engineers. Because let's say, okay, I know one of the companies I talked with, they had such a big platform team that it makes sense, right? If there's like 50 people in the platform team, then that's okay. If there is a DevOps dedicated to each team, makes sense. I don't need the developers to do anything when it comes to the infrastructure. Not self-serve, that's already kind of understandable. Okay. So another thing that I saw was multiple umbrella charts. It means that we have many services and they're all inside one big chart. And it means that some places divided it either by team or by a product, which means that I can have some apps deployed together. The same idea as I talked lengthily about the umbrella chart, but now we're talking about separate, maybe individual products or teams. And the problem is that if you decide that you want to have something that is spread across all of those charts, you can't do that. You need to go ahead and change it in all of them. Again, this makes standardization very difficult, because when I say Team 1 umbrella chart or Team 2 umbrella chart, it means that those charts might be sitting in the repositories of those teams. Maybe there is a dedicated repository, something that is managed across multiple repositories, which means that if I want to make a wide change, it's going to be annoying. if I put it in simple words. Um, so this is when we, after I explored all of these options, I knew that there must be something in the middle. There must be a way where I can take some of the good of each of those solutions. And the thing was that I got inspiration from Jenkins, which is weird because the developer experience of Jenkins is debatable. Although I personally like it, I heard different opinions. Don't tell me what you think. But I took inspiration from Jenkins when I came to the team and discussed the solution that I'm going to show you in a bit. The thing was this. What I liked is that in every repository, there is a Jenkins file where you can define custom steps for your CI pipeline. But we also have one big Jenkins file that runs and manages all of the pipeline itself for the CI. So the main Jenkins file, it always runs. This is what's managing the CI. But then if you in your repository want to add custom steps or to change some values or to do something a little different that is custom made for your own app, you can do that. So this way I can have both things. I can have the standardization and I can I can allow the developers to add more things or to change more things and adapt it to their own needs. Or if they want to go with the golden path, all they need to do is just to have the general Jenkins file in their repository without any changes. And I wanted exactly that. I wanted something like this, that I'll have something that is central, but then also something that developers can change and adapt to their needs. And this is our base chart solution. Each service that migrates to Kubernetes will have a Helm chart that contains the configuration of the service, containers, environment variables, all of that in the service repo. What did we do with the existing infrastructure? I'll talk about it in a little bit. So the base chart will serve as a dependency in each service chart, and then we will have an individual chart for each service. So if we look at that in a more visual way, we will have the base chart over here, and this is where we define the templates, the values YAML, and the chart YAML. And then every service is dependent on that chart, which means that if they want, as a golden path, all they need to do is define chart YAML and values YAML, where they can define, the name of their service. They can define how many, the pod count or the replica count or any other value that they want. Metrics, all of that can be defined in the values YAML. But if they want to add more complexity or more features, they can by just adding more templates and more configurations, that are better fit for their own application. I think the thing that I love about the base chart is that we called it Chartmander, like the Pokemon. Nobody laughed. What? I thought it's funny. It's cute. Okay. All right. Maybe next time you'll laugh at my jokes. Anyway, let's go back to that. So this is what it will look like this is what our base chart looks like. These are the things that we currently define in it. And now let's see what it would look like for a service. So a service will have the chart itself, and as you can see, each service will have the base chart as a dependency. What it means is that we can now release new versions of the base chart each time, and we can add more and more things, and all the developers needs to do is just to mention the base chart as a dependency in their chart YAML, because we have auto advance, which is our way of advancing dependency throughout the repositories. They don't even need to care about versioning unless we have break-in changes, but that's that's something that I guess we should discuss in a different time, because it's a whole complexity issue. Not for now. Okay. So one important thing that we loved was that the service can override values of the dependency chart. Let's say if I define that a replica count is 1, they can change it to whatever number that they want. Another cool thing that we did is with the metrics, we decided to put the metrics enabled false for everyone, and if somebody wants it, they can enable it to, they can change it into true. And that's it. So the thing is that important to say is that the base chart values file will contain all of the default values, and these can be overwritten. So again, if the developer want to stay on just defining the chart name, they can, and then that's it. And that's the dependency services chart. Okay, so see the little chart? Okay. So, so the base chart, for us, it meant that we found the balance between the developer autonomy and standardization, because now the developers can have all of these things. It is self-serve because the developers can write their own chart YAML and values YAML, and then that's it, and they don't need us in order to deploy it, to create a new service and deploy it to Kubernetes. Also, it's composable. I will talk about it in a little bit, about the additions and changes that we made to the base chart, but it's very easy to add more things to it or to take apart things from the base chart. And then also, it's extensible. We saw a lot of developers adding their own templates or getting charts from third-party Helm charts, and we did, it was the responsibility of the security team to make sure that those third-party Helm charts are valid, but it was possible. And this is my responsibility, to make sure that they can add it, and then the security team should make sure that it's actually safe. So now let's talk about what we did with the existing infrastructure as code. If you remember, we had that Python solution using CDK and also CDK test. What I didn't mention, I think, is in the first iteration of our Kubernetes, we actually used Python to generate the Kubernetes YAMLs. We used CDK test. And it meant that, we thought at that time that the developers are already used to that Python solution, so why not continue using that API? And it was too complex for them. It was too complex. It was maybe it's not complex and they just didn't have the time, which is also okay, because some developers feel that it's not their responsibility to generate their own resources. So we knew that, okay, now that Helm is defining resources for Kubernetes and it's not part of that Python solution, we still need to find a way to connect the two, because there are things that are defined in that Python solution that we're going to need in order to deploy the service to Kubernetes. So things like IAM role or the URL of some queue or the ECR URL, those are things that are used and they are needed, for example, for the defining a service account for Kubernetes. So we knew that we still need to find a way to get those values from that Python solution. So what we did is we added a little part to the Python solution, Python service, that generates a values YAML. So some of the resources, everything cloud related, is still defined in the Python repository. So for example, if I want to define a new S3 bucket, if I want to define an SQS, when I create a role for my service, so that's the way that I am getting all of the permissions, the IAM role, that all of that is being created in the Python solution. And then we extract from that values YAML, and then during deployment, Argo CD takes both the values YAML from the Python solution and the values YAML from the Helm chart of the service, and then it deploys those together. And now, okay, what I wanted to say now is that what you can see over here, that each chart can be deployed separately, but it got to the point that the base chart got pretty big. It was a bit too much. So now what we started doing, and that's something pretty recent, is that we took apart the base chart, and we now have base charts for security things. We have a base chart for monitoring. We have base chart for networking. And we also start to work on taking apart that Python repository. So we extract things from there and we add it to the base chart. We still call it base chart. There is still one chart mender. I can't give up on that name. But to be honest, we now have several base charts, because having one just meant that we ended up again with a very big repository, which we didn't want to have. So now we have several base charts defined by different purpose. And yeah, so this is what, okay. So what have we talked about today? We're getting closer to the finish line of this talk. And I believe that I mentioned, I believe that I mentioned at the beginning how I'm going to show you a bunch of technical things that you might already be aware of, you might already know. But the thing that I want you to really think about when you leave this room or you leave this live stream is that you can't decide for your developers what they want. And you can't expect 120 developers or 10 developers to go and learn something that maybe is not in their main path. It's nice if the developers, can open their mind and do extra, but you can't expect that from them. You can ask them if they want to, if they're interested in it, but it's not something that you can rely on. And if you have that thought in mind, that I can't rely on the fact that they know Kubernetes to the core, they understand the implications of defining different resources in different ways. If I know that, it means that now I will develop solutions that will work with it. And if there are power users that know a lot about Kubernetes, great. I love it. But for the rest of those developers who are power users in their own thing and whatever it is that they work on at that moment, I don't have to be worried. If it's worried about security, worried about cost, worried about production issues because somebody didn't define a pod destruction budget, So that's what I want you to take away from this talk. Remember that you're working with developers who, at the end of the day, want to do a good job as much as you do, but they have a different job definition than you. And this is how we defined the requirements for the Helm solution. It wasn't just technical requirements. It was mainly requirements that would be the best fit for our customers, which are the developers. And with that, I will say thank you.